So chapter 2 is talking a lot about maps, a lot about data, how it's all kind of, well, how it's used. So quantitative data and qualitative data, right? Quantitative data, this tends to be, well, pretty reliable numbers that you could get about different things. And sure, you do an analysis of it, and you may have qualitative questions about qualitative data, different type of data. It's kind of, well, called kind of mushy data a bit. Qualitative data, classic example is like an opinion poll or a survey. And although those end up with numbers that you could analyze, you always have to keep in mind that these are a bit more subjective, right? The field of geography uses a lot of data, and a lot of different data can kind of be brought together from different sources and analyzed. Probeware, well, as you can see, it says probes and sensors integrated into computer software, collect real-time data. So for example, here at St. Thomas, we do have GIS classes that are map making, and people use remote sensing. Sometimes this could be satellite data. Increasingly, we're using drones that could just kind of fly up and take different types of pictures and data analysis of different landscapes. And then you have all that data that you could put into a map, and you could do different types of analysis of. Who collects all this data? Well, a very useful data set is, of course, the census. Happens pretty regularly, but it takes them a while to publish it. So, for example, the 2020 census, they still haven't now published all of the stuff yet. There's a plan of a final publishing, I think, that's supposed to happen this fall and winter. But there's so much data in the census that it just takes a lot of time for it to organize and get it into a shape that could be published, so that then academic institutions or even companies can use that data. Data, well, in the information age, is becoming kind of one of the most important things, and a lot of companies, the more data that they have, the kind of more powerful they often are, because they use that data for all kinds of things, right? And increasingly in our age of AI, hopefully it'll be easier to kind of digest and analyze this data, because you'll be able to just dump it all into an AI and ask it some questions and have it take apart the data and help you figure it out. Because the amount of data that we're getting now is just a bit overwhelming. Lots of data sources, lots of data. GIS, well, I was mentioning this already, Geographic Information Systems. This is the mapping software that's used, and there's a number of different types. There's one main, ESRI, which it's kind of like the Microsoft of map making. It's the one that most people use, and although there's alternatives, it's the main one that people use. And the science of map making and map use has changed a lot through time. I would say, well, I've said before how I'm super old. When I was in college taking my first geography classes, we had to do our maps by hand, as crazy as that may sound. We would take sheets of paper that you could see through, you put it over the map that you want to map, you would trace over it, and then you write in the things that you wanted to map. And you use different tracing, and it was a very laborious and time-consuming process. But now, computers, you just throw that data into a software system, and it will organize it and put things in places that make sense. Geovisualization, this isn't just maps, but just kind of any way you could help visualize that data in one way or another. Typically, maps have layers, and I don't know how much people interact with maps. Probably you might use it every day, and directions on your phone. Your phone ones may have some different layers a little bit. Very often not. I think the most common thing that you could click that people do these days is to switch to a satellite view from a street view, just to kind of get a better visual of what's going on. But these layers are just the different types of data. And usually they'll just be a box you can click and you'll turn them on and turn them off. Because sometimes bringing the data together can be more helpful than not. So in this example, well, they're bringing together analysis of the different speeds of the different roads, and then you put over that the different places, right? So you don't want just a map of just roads, and you don't want a map of just places, but you want to bring these together to help you figure out where you're going. As I mentioned, a lot of remote sensing is being used, increasingly drones. There's a lot of satellite data though, the info. There's also, historically, they take closer photos using helicopters or planes of different geographic areas that just could get more detail than satellite images can often get. And GPS, like I said, most people actually use GPS pretty regularly, so you probably basically know what it is, but it's navigation, right? Actually, I'm not going to go through those definitions. Map scale, that is, well, on usually any good map, you'll have a section that will just tell you how much these distances are, right? So 1 inch equals however many miles or however many feet or whatever amount. Usually they'll have a good little number fraction, but sometimes it's written, sometimes there's a little chart. Map projections, which I think we've talked about a little bit already. Let's see. Did we talk about these different types of map projections last time? Doesn't ring a bell? Well, there's lots of different ways to display the same information, right? One of the most popular GIS books was called How to Lie with Maps. And you might think, well, why would you be learning how to lie with maps? The point of the author was that all maps kind of make a decision of what they're going to show and what they're going to not show, right? And so when you're looking at maps, very often kind of have in your mind, what are they not showing, right? Why are they not showing this thing? So for example, 3 different map projections of the same thing, right? But they look quite different. I would say this map here being a Mercator projection, it's the same projection as on that wall there. It's historically been kind of the most popular projection, especially during, the 20th century. In many ways, the map kind of became a bit controversial through time because it was felt that it makes certain countries look bigger relatively than other countries, right? So what does that mean? Well, so in this type of map, because you're taking a round thing, right? And you're putting it on a flat surface. So no matter what, you can't have a specific accurate representation of this. Even this globe itself is not an accurate representation of the Earth's surface because the Earth is an oblate spheroid, meaning it's a bit squished and it's a bit wider in the sides. So this is being a perfect circle. It's also not as accurate as you may think. So what this map does is everything is accurate on the equator. And the further you get from the equator, the more it's stretched out, right? And the argument was usually made that this type of map is better for navigation because all the shapes of everything are correct. It's just that the sizes are not correct, right? But as I said, well, let's jump to this map here. This is what's called an equal area projection map. What that means is, whereas this map has all the right shapes but the sizes are wrong, this map has the sizes all right, but the shapes are wrong, right? So if you look at a map where the sizes are right, you'll see that things around the equator are actually much larger than these types of maps would lead you to believe. So for example, on this map, right, Europe, it's like, oh, Europe's a huge place, right? Europe's way bigger than India. Like, Europe is like bigger than Africa, according to this map, right? It's like, well, what a huge, huge place. And Russia is gigantic. Russia's like half the size of everything else. Not to say Russia isn't large, but it's not that large. One of the biggest ones is, of course, Greenland, which is larger than all of South America in this map. Now let's go to an equal area projection where the sizes are right? But Greenland is not so much like this. These shapes aren't right. But Europe, right? Is it bigger than Africa? No. It's it could fit in a little part of Africa, right? It's tiny. Russia, although it's a large place, it's not this massive thing that it looks like on the other map. So these are correct if you're trying to think of how actually big are these different places. This here is called the Robinson projection, and that's actually the most widely used these days map, right? That is this map. And whereas this map has the correct sizes but not shapes, this one has the correct shapes and not sizes, and this one, everything is wrong. Everything is wrong, but less. It's less wrong. Do you know what I mean? And so it's considered a kind of in-between point, because you get mostly the shapes right, and you get mostly the sizes right. So that's the most popular one these days. So let's see, looking at different types of maps. Reference maps, I would say that these are the maps often if you're just trying to drive somewhere, or maybe you're trying to look at planning a trip and you want to look at where the different state lines are. Maybe you're looking for, big national parks or something. You might get a map that is specifically about that, identifies those things. Reference maps, pretty simple concept. This is one of those historical maps from the book. This reminds me of the days when we would have to hand draw our maps, and they would also be often very inaccurate.
It's interesting with the previous map.
Yeah.
You can tell where they've been and explored and where they haven't.
Yeah. Yeah, I would say they really got Antarctica wrong. Well, and Australia.
And like the top of North America.
No, that's right. Right. Map at night. Thematic maps. So there's all kinds of different ways to show data. These are a bunch of the kind of main types of maps. I'll just show you examples of them, and they'll make more sense. An isoline map, just about any time you're looking at the weather forecast, they usually use isoline maps. What that means is along this line, the data is the same, right? So usually if you're looking at temperature maps, right, if you're looking at the weather, this map is, I believe this is temperatures in July. This is the area that usually gets the most sun. And so it's not that much of a surprise that in general, on average, has higher temperatures. Graduated symbol map. Actually, this doesn't say what this is a map of.
The size of the circles relates to the relative amount of gasoline consumed.
Gasoline consumed.
The more gasoline consumed. And so then it's gallons for the key.
Yeah. So why are these ones all so small? Yeah.
No one lives there.
Well, less people live there. I recommend going and visiting these areas. They're very, very pretty, very scenic. But yeah, right? And some of these states have a combination, like Texas and California, they have a combination of it's not that nobody lives there, people live there. Not only do they live there, but these are actually very sprawly states, and so people tend to have to drive a lot to get to where they want to go. Graduated symbols map. It is what it sounds like. The larger the symbol, the larger an amount. Cartogram. This is, although it might not look like it, this is a population map, right? And what they've done is they've just made the states relatively the right size compared to each other as far as population. I think that's what this is, right? Populations. And of course, they don't care about the shape. All they care about is the size comparison. Dot matrix map. This is milk producing cows, I believe, is what this one is. It doesn't say on here, but if memory serves. And so, you know, this map, if you wanted to know where milk producing cows are, you know, Minnesota has a fair amount of a dairy industry. If you might deduce from this map that Wisconsin has more, you'd be correct. You'd be correct. Through time, Wisconsin has been actually taking the milk market from Minnesota, and Minnesota's dairy industry has been in decline. Yeah.
One dot equals 2,000 milk cows.
Oh, 2,000 milk cows. All right. Something that I don't know if this will surprise you or not, but California actually has a very large milk industry. They're another big competitor, and they have the advantage of, you know, you have a big population here, and so the relative speed of moving milk around. A lot of the milk industry in Minnesota, it's actually very often farmers don't plan on making a lot of money from it. They do it as kind of a thing to do with excess crops or whatnot, is you have some cows, feed them and get the milk, but it's not a big money making thing. But I don't know, people have probably heard the concept of creative destruction. Something is destroyed, often something new is created. The dairy industry going under in Minnesota has actually influenced the local beer brewer industry, because it's a lot of the same equipment. And so people, if they want to have their own brewery, they could find some very cheaply for sale from dairy industry that's going out of business. So that's one of the reasons why, if you ever notice, we have all these different breweries all of a sudden. Well, those are people who are buying the same equipment. Precipitation maps. As you can see, these are using the different types of maps, right? We have the dot matrix, and then we have isolines. I would say, you know, what are some things that the different types of maps help you see? I guess I personally would prefer the isoline map, because I feel like that gives you more solid data. But like I said, when you're looking at maps, keep in mind why the map maker decided this type of map. Often it might be because it doesn't have this much data, it might just have much less data, and so therefore would have to have a different type of map. Multiple layers. Time's going. Well, this of course is bringing a bunch together, which you can, as a map maker, you could decide to put different layers, have them viewable at the same time, and that could give you a better idea of a number of different things. So for example, in this one, well, wanted to look at fires and fire spread. They also wanted to look at where exactly is the Amazon, right? Mixing those visuals together can give you some good info. Give you a good example of, well, if you're looking at preservation efforts, right? If you're looking at fire prevention efforts. Choropleth map. Choropleth map, choropleth just means inside of any shape, you'll have one color, right? And so this is election map. Is this from 2020? Yeah, it must be. So if you look at this map, you can get a quick visual guide of kind of where the votes went and whatnot. People know why blue and red were picked as colors for these political groups. Well, in general, map makers try to stay away from the color red because the color red tends to culturally mean like warning, bad thing, right? So they tend to stay away from red. Well, in the 2000 election, before the 2000 election, different kind of random colors were used when they're doing map analysis of voting and who people would vote for. But for in the 2000 election between Bush and Gore, the main networks all picked the same colors. And they didn't coordinate this, but they all went through the same mental process, which was this. You have a Democratic Party and a Republican Party. Our flag has red, white, and blue, right? And they're like, well, that seems like we should use those colors. Well, the question came down to, do we decide one party is the white color party? No, I don't think we should do that, right? They're like, well, then we have red and blue. Well, what do we pick? Well, there's a history of politically people trying to paint the Democrats as being communists, right? Especially in the 50s. And the networks are kind of like, well, we don't want to like insinuate that. So we'll just have red be Republican. Starts with the same letter, so why not? And we'll have blue be Democrat. Like I said, it wasn't coordinated, but they all went through the same mental process. And then during the election, they were all using the same colors. And then it just became the standard. So this is a cartogram. As you can see, this is going by whole states in the votes, but it's also making the states size, well, we saw an earlier map of the same thing, but it was using random colors. This one, right, puts in different layers. It puts in the votes that these states got, and then their relative size depending on their population. And so it's one of those things where if you look at this map, right, you'll have kind of one visual for where the vote went, and whereas this map makes America look more red than blue, right? The population map, it makes things look a little more divided, right? Another choropleth map. And these are all from the book. Like I said, they sent them in today, so I actually have them to use. This map of cumulative COVID rates through July of 2022. This map is actually quite a bit different than, I don't know, people were, you're all pretty young at the beginning COVID days. Do people remember what areas had the first and the most cases originally when COVID was going around? Yeah.
New York.
New York was one of the big places, right? Cumulatively, it's more in the middle, right? What was another big place that had a lot of COVID at the very beginning? Anyone remember? California. But now when you look at cumulative rates, it's not in the top. People know why that would be different? Well, the places to get COVID first and in the most amounts were travel hubs. Places with huge airports, right? You get a lot of people in and out internationally, right? Those are big international travel destinations. So that's where it was at first. And so that's where the first places were. Through time, though, that's changed up a bit. Yeah. This map being cumulative COVID rates, this is a map that is more going to tell you about states that have higher vaccine hesitancy and things like that, right? Things that happen much later and not the first intro days. Let's see. Well, I'm running short on time, so I think think I'm gonna have you guys in small groups, gonna have you work on some questions. And today, I'm gonna form your groups. I'm gonna do this, well, I'm gonna come out and I have a bunch of cards that I did not shuffle. And what I'm gonna do is, people are gonna be grouped by the suits, all right? And why do I do this? Well, it gets you working with different people. So I have some pretty easy questions for you to do in your small groups. I'm just gonna have everyone take a card. Oh, hand one over time. All right. Good to see you, buddy. All right. Looks like the smallest group is going to be diamonds. Who has diamonds? Who has diamonds? Oh, there's a cluster in the back corner of diamonds. All of you collect over there. Work on these questions. Same scenario as before. Who has hearts? Hearts. Has to be more hearts. Actually, there's a cluster kind of here, plus there's empty seats. So come over here for hearts. Who has spades? Who has spades? Oh, I think there's a cluster back there in that corner. Spades. What have I forgotten?
Clubs.
Clubs. Who has clubs? Clubs can cluster here. All right. Move to your groups. Introduce yourselves.